Hello everyone, I hope you're still fine. So in our last lesson we looked at the definition of fractions in details. We also managed to look at some practical applications of fractions, and then finally we looked at the different types of fractions. So today we are going to move on and try to wind up on fractions. I hope we are ready. So we shall start with equivalent fractions. Equivalent fractions are fractions whose value is the same even though they may look different. We can therefore say that equivalent fractions are fractions with different numerators and denominators that represent the same value or proportion of the whole. To understand this more, let's look at the diagrams below. In figure 1, we have a circle which is divided into a half, and therefore we have each part equivalent to a half. Furthermore, we divide our circle into 8 equal parts, as you can see from the diagrams, and in so doing, we see that the former 1/2 is equal or equivalent to 4 out of 8. Since a half and 4 out of 8 are the same, they are called equivalent fractions. Why? This is simply because the value of the two fractions is the same, even if the fractions themselves may look different. The same also applies for fractions, a half, 2 out of 4, and 4 out of 8, which are equivalent, as seen in figures 1 and 2. So we are going to proceed and look at another subheading, and that is the lowest terms. A fraction is said to be written using the lowest terms if its numerator and denominator are relatively prime. That is, they have no common factors other than 1. For example, a half is in its lowest term, but 2 out of 4 is not in its lowest terms, because the top and the bottom can both be divided by 2. Also, we can't say 2 out of 4 is not in its lowest terms because the numerator, which is 2, and the denominator, which is 4, are not relatively prime. That is, they have a common factor other than 1, which is 2. So we can't say that if both the numerator and denominator can both be divided exactly by the same number, the fraction can be reduced to its lowest terms. We can now proceed and look at some practical examples, and in these examples we are supposed to reduce the fractions below to their lowest terms, of course where possible. We are going to start with Roman 1, that is 3 out of 4. In Roman 1, we can see that 3 out of 4 is already in its lowest terms, since there is no number that will divide exactly into 3 and 4. And also because 3 and 4 are relatively prime, we can therefore conclude that 3 out of 4 is in its simplest form. We are going to proceed and look at Roman 2, which is 5 out of 10. In this fraction, 5 out of 10 is not in its lowest terms, since the top and the bottom can both be divided by 5. And also since 5 and 10 have a common factor other than 1, which is 5. So we simultaneously divide the numerator by 5 and the denominator by 5. This will then simplify to a half, which is in its lowest terms. As we move on, the same applies to 8 out of 12 in Roman 3, which is also not in its lowest terms, since the top and the bottom can both be divided by 4, which is the common factor of both, hence giving us 2 out of 3 in its lowest terms. I hope this is quite clear. So we move on, and now we are going to be looking at operations on fractions, and we shall start with addition and subtraction of fractions. Well, if the two fractions being added or subtracted have the same denominator, then we just add or subtract the numerators, but keeping the same denominator in order to get the final answer. But of course, not forgetting that the answer should be given in its lowest terms where possible. It should also be noted that we don't add or subtract the denominators during addition or subtraction, since the denominator only indicates how many equal pieces make one unit. So if you add the fractions, the new denominator won't actually describe how many equal pieces are in one unit. So here we shall try out a couple of problems involving the same denominator. And in Roman 1, we have a quarter plus 3/4. Since the denominators are the same, we only add the numerators. and it will give us 1 plus 3 to give 4 out of 4. Then we simplify, and then we shall end up getting one whole number. I guess that was pretty nice. In Roman 2, we are going to subtract mixed fractions, but still with the same denominators. So here we go. 3 whole numbers, 1 out of 5, minus 1 whole number, 1 out of 5. Well, first things first. Convert the mixed fractions into improper fractions, and then we shall get 16 out of 5 minus 6 out of 5. With the same denominator still, we subtract the numerators, and we shall end up getting 10 out of 5, which can be simplified as 2. As we proceed, we are now adding to addition and subtraction of fractions with different denominators. When adding or subtracting fractions with different denominators, we make sure that the denominator becomes the same before we start to add or subtract. The reason fractions need a common denominator before adding or subtracting is so that the number of pieces you are adding or subtracting are all of the same size. And to do this, we get the LCM of the denominators. This then becomes the new denominator when adding or subtracting fractions. Let's understand this more with the following examples. In Roman 1, we are having a half plus a quarter, and then in Roman 2, we are having 2 whole numbers, 1 out of 5 minus 1 whole number, 1 out of 4. And we are going to start with Roman 1. Step 1 in Roman 1 is to first get the LCM of 2 and 4, so that we can get a common denominator. And we can see that the LCM of 2 and 4 is actually 4. Therefore, since the denominator is now the same, we just add the numerators. That is 2 plus 1 to get 3 out of 4 as our answer. So we can proceed to Roman 2. 2 whole numbers, 1 out of 5, minus 1 whole number, 1 out of 4. For Roman 2, the same steps are followed. That is, first we change the mixed fractions into improper fractions. Therefore, we get the LCM afterwards of the denominators 4 and 5, which is 20. Then the new denominator 20 is divided by the first denominator 5 to give 4, which is then multiplied with 11, giving us 44. Also, the new denominator 20 is divided by the second denominator 4 to give 5, which is then multiplied with 5, giving us 25. Finally, we have 44 minus 25, and everything is over 20, which is our denominator, thus giving us a fraction 19 out of 20. As we can see, 19 out of 20 is already in its simplest form. So we are going to move on, and we go to multiplication of fractions. Multiplying fractions does not require that the fractions have the same denominator. Instead, the numerators are multiplied with each other and the denominators with each other. To multiply fractions, simply multiply numerators together and the denominators together to get the answer, which we will give in its lowest terms. Also, if the answer turns out to be an improper fractions, it is also usual to turn it into a mixed number of fractions. It should also be noted that before starting to multiply fractions, change any mixed numbers into improper fractions first. This is very important. If it's fine, then we can move forward and look at some examples. In Roman 1, we have 2 out of 3 times 5 out of 7. When we look at this example 1, remember that earlier on we said that when multiplying fractions, we simply multiply the numerators together. That is 2 times 5, which are our numerators, and the denominators together, that is 3 times 7. This will give us a fraction 10 out of 21. And as we can see, it is already in its simplest form. As we move on, in example 2, 1 whole number and a half times 4 out of 5. In example 2, we are going to be dealing with a mixed fraction. Still, Like in the previous example, we have to multiply numerators together and the denominators together. But before we do this, first we convert any mixed fraction to an improper fraction. This then gives us 3. This then will give us 3 out of 2 times 4 out of 5. On multiplying the numerators together, we get a new numerator, which is 12. Furthermore, as we multiply the denominators together, we get a new denominator, which is 10. And eventually our answer is 12 out of 10. And of course, on simplification, we do get one whole number, 1 out of 5. And by this, it is in its lowest term. We can now proceed to division of fractions. So to divide fractions, we shall be following the following steps. Step 1. Before starting division, change any mixed fractions into improper fractions. Step 2, find the reciprocal of the divisor fraction, or we can simply say invert the divisor fraction. We can therefore note that the divisor fraction is the fraction right after the division symbol. For example, when we look at the example below in Roman 1, our divisor fraction is a quarter. I hope we are together. Okay, we proceed to step 3. Multiply the first fraction by the reciprocal of the divisor fraction. And then simplify the resulting fraction where possible. So as we move ahead, we're going to be looking at some worked examples, and we shall start with Roman 1, a half divided by a quarter. In Roman 1, we have a half divided by a quarter. Now, in this example, our divisor fraction is the one right after the division symbol, and this is a quarter. So we are required to get the reciprocal of this a quarter, which will give us 4 out of 1. And this means that also the sign changes to the multiplicative symbol. Therefore, we multiply the numerators together and the denominators together. That is 1 times 4 as our numerators and 2 times 1 as our denominators. This will give us 4 out of 2, and on simplification we get 2. So let's proceed and look at Roman 2, which is 1 whole number quarter divided by 2 whole numbers and a quarter. We're going to be dealing with mixed fractions. Therefore, first thing is to change the mixed fraction into improper fraction. After that, as usual, we shall be getting the reciprocal of the divisor fraction, which is in this case 4 out of 9. So this will give us 5 out of 4 times 4 out of 9. After that, we multiply 5 with 4 together as our numerators, and also we do multiply the denominators 4 and 9 together. This will give us 20 out of 36, and on simplification we get 5 out of 9. I hope we have learned something quite amazing about operations on fractions. Now we have a simple exercise for you. Try to do it and therefore enjoy. See you again.